Hi friends, this is Hazarath Kshatriya from IIT Kanpur. Welcome back to interview guidance session. Let us discuss a very interesting question, that is differentiate pressure and stress. It is very popularly asked in many PSC interviews. You should have full command on the pressure and stress. Come to the definition of pressure. Pressure at a point defined as the magnitude of external force acting per unit area of cross section. Now come to definition of stress. That is stress at a point defined as the magnitude of internal resistance offered by the body per unit area of cross section. Stress equal to internal resistance offered by the body per unit area of cross section. This is sigma, it will be P. Now, if this question asked in the interview, almost 90% of the people will give same answer because everybody knows the definition of pressure and stress. But we need to give a different definition for pressure. That is, we need to start from molecular level. See here, pressure associated with the molecules. When these molecules strike the surface, velocity of the molecules will change. Due to change in velocity of the molecules, change in momentum coming to picture. The rate of change in momentum is nothing but force. The magnitude of this particular force acting per unit area of cross section is called pressure. Pressure always applied externally. It always compressive in nature. I want to give a single statement answer to differentiate pressure and stress. That is, if I pressure you, you will feel stress. Enough. Both the definitions are covered in single statement. See here. If I pressure you, you will feel stress. That is, feeling should come from internally, pressure applied externally. Okay. Here, if your guide pressures you, you will feel stress. Okay. That is the single line statement for differentiating pressure and stress. Due to pressure, stress will be induced, but due to stress, pressure can't be developed. It is very important statement. One more thing here is pressure at a point always compressive in nature, but stress may be either tensile or compressive. Okay, pressure is a scalar quantity. It is a zero order tensor. Stress is a second order tensor. We know scalar na. Scalar is a zero order tensor. Only magnitude is sufficient. Go to some higher order. Vector. To represent a vector, both magnitude and directions are required. So that is first order tensor. To represent stress, we need 9 components. That is why we need to move higher order. That is second order tensor. We need to represent stress tensor in terms of 3x3 matrix for triaxial state of stress condition. Coming to other examples for second order tensor, those are moment of inertia. It may be either mass moment of inertia or area moment of inertia. Both are second order tensor. We need to represent moment of inertia in 3x3 matrix. Coming to rotation and image, both are orthogonal tensors. You can call it as a second order tensor. It is an orthogonal one. Take care that if the determinant of orthogonal tensor is +1, you can call it as a rotation matrix. -1, image matrix. Transformation is a combination of both rotation and translation. Translation is a first order tensor, that is vector. Transformation is a third order tensor. This is all about some basics regarding tensors. In that family, stress will come under the category of second order tensors like strain. Strain also second order tensor. According to Pascal's law, pressure at a point equal in all the directions. That means it is independent of the direction. That's why we are calling pressure as a scalar. But stress at a point is not equal in all the directions. That depends on the loading condition. But pressure at a point equal in all the directions. Pressure can be measured by using manometer, but there is no equipment available to measure the stress. But normal strain can be measured by strain gauges. I conclude that pressure defined as the magnitude of external force acting per unit area of cross section. Stress is the internal resistance offered by per unit area of cross section. Pressure is a scalar quantity. Stress is a second order tensor. Pressure at a point equal in all the directions, but stress at a point not equal in all the directions. It depends on loading condition. But for hydrostatic state of stress condition, stress at a point equal in all the directions. Okay? Pressure can be measured, but stress can't be measured. Okay, your normal strain can be measured by strain gauges. That is the input to derive all the expressions of stress that you already seen in strength of material course. Okay, this is all about some funda regarding pressure and stress. We know that stress is a second order tensor. This is box representation of the stress. Here sigma xx, x phase and x direction. Here it is tau xy, x phase and y direction. Here it is tau yx. Here it is y phase and z direction. Tau z phase and y direction. Z phase and x direction, x phase and z direction. This is box representation of stress. Stress is a second order tensor. Now matrix representation of the stress in 3D. Sigma xx, tau xy and tau xz. Tau x sigma yy, tau yz, tau zx, tau zy, sigma zz. Okay, this is matrix representation of the stress. Now if it is 2D, for 2D sigma x, tau xy, tau yx and sigma yy. This is for 2D. We need to prove tau xy equivalents to tau x. State of stress diagram at a point for pure torsion case. See here, this is, here it will be like this. Here it is x phase in y direction, xy, this is y phase and x direction, tau yx. I converted all the stresses into loads. Here tau xy into BC into 1. Stress into area is nothing but force. Tau xy into BC into 1. Tau yx into AB into 1. I converted all the stresses into loads. Now apply moment about point D. Moment of these two forces about point D will become 0. Moment of tau yx into AB into 1 about this point will be anti-clockwise direction. Moment of this force about this point will be clockwise direction. Sum of the clockwise couples equal to sum of the anti-clockwise couples. Taken sigma md equal to 0 for equilibrium condition. Finally you got tau xy into BC into 1 into 1. Tau x into AB into 1 into 1. Finally, you got a beautiful expression that tau xy equivalents to tau yx. I got this question from my friend. Okay, so he faced this question in IISc Bangalore interview for M.Tech. Here, interviewer check your knowledge in whether the student is in position to draw box representation of the stress and matrix representation of the stress. What is the meaning of tau xy? Tau xy. Shear stress on x phase in y direction. X phase in y direction. And whether the student is in position to derive tau xy equivalents to tau yx. So that is very, very important. Some good input to the students. Here stress is a second order tensor. We have drawn box representation of the stress and matrix representation of the stress. Finally proved tau xy equivalents to tau yx. This is all about some introduction regarding stress and pressure. Thank you.